so April 1st. So sprint 2. So we are here. If you're missing sprint 1 or 2 or anything, now's the week to really put forth or start to sustain an effort, because we got lab times now Monday, Wednesday, Thursday, and April 8th is the last day to drop. So if you're behind, now's the week to come in, see the TA, and see if you can put forth that double time effort to wrap up and get caught up, because the drop point is next week. The TA is currently grading sprint 2, so it'll be available sometime midweek. I'll send out an email when the grades are up. And if you can't find grades, just know that in Moodle, there's this options drop down tab, whatever, and there's grades. All right, so you should be able to see your grades. And just come see us to wrap up if you're behind. So last week was the beginning of sprint 3. I went over kind of the basics of animation, just creating one animation that your paint stroke does, and I wanted you to at least try to go forward and attempt to create your own animation, whatever it is, based off what I'm doing. This week we're going to be doing prefabs with multiple objects, prefabs with multiple animations, and then how to transition between those animations, and then how to promote some features through the user interface. So as I was saying before, I'm only going to cover of the material I've yet to cover. I'm going to hold off, not do an online video or additional material this week, because we have an hour to get through. It's kind of deep, it's new, so I'll hold off and create and wrap up the rest of the content for next week. So here we are. We still have a week of work. We got a week of work next week, and then you got to drop right before class, and then we move on to sprint 4. So that drop point will be, looks to be, like Sunday night at midnight, April 14. I'll have to update this section here, April 14 at midnight, and then we move on Monday. So sprint 4 will be heavy with a common technique or name, I guess, in software engineering is refactoring. It's where you go back, you clean up your code, you clean up your names, your methods, how they're being called, so that other people it's easier to use, or you get rid of your bugs. In this case, we're going to refactor in a situation where we've just been exposed to animation, and as I said, certain parameters that you grab with animation, you're not going to be able to grab directly with code. So some parts of our user interface in some ways might be broken. You might not be able to dynamically update like some scaling or some color information, because it's being driven by your animation. So I'm going to show you some techniques today to kind of minimize that effect. And then sprint 4 is, well, let's look at a lot of these loopable animations. How can we redo them in code so that now the user can have like full dynamic control over modifying this stuff while our animations are still running? So that'll be like the last 3 weeks of class, moving off this animation system into code. And then on the last day of class, the day before, you're going to drop. That's going to be May 5th at midnight. And then at May 6th, you just come in for an hour to take the final. So everybody voted just to take the final. That last day of class, don't go into finals week. The final will be under an hour. It's going to be like 30, 40 multiple choice short answers. Short answers are less than a sentence. It's like, explain this topic to me, just write a sentence. Multiple choice, true, false. I'm not sure yet if there'll be any pseudocode. Last semester we had a few, but it's just like, hey, if I want to randomly select a color, how would I do that? And you'd kind of write out what the steps might be. I'd have to find a way to find the object, maybe find the render, maybe somehow to randomize some floats and how to assign them to a color variable or something like this. The final exam is heavy on is entirely what we've been doing. So user flows, interaction design, user interface elements, C sharp programming concepts like variables and if statements and for loops. Any data structures you've been exposed to, vectors, yeah, vectors of 3 parts and of 4 floats for colors. So anything that you've been following along and doing, that's what's going to be on the final. Any questions on that? And then at some point I'll get up like a review sheet, like these are the topics and what have you. All right, so sprint 3 is just following along with the other sprints. So it's very similar to sprint 1, sprint 2. Now we have our 4 features. And I'm just going to ask you to create the 4 features that I'm doing. It's the amount of effort is probably half code, half animation. And again, animation is very subjective, designy. So I'm just looking that you're doing it, and it's not like that there's some variability, that you put some effort into it. So the 4 user flows are that you have 3 prefabs and 3 animations per prefab at least. So you have some variability to the user. Oh, my arrows were a little messed up there. There we go. That you have a user interface element for changing the animation type. In my case, I'm using a drop down, and my animations are just based on scale, position, rotation. That you have some way to change the animation speed. In this case, it's a slider. I gotta update that. I'll do it later. And then I'm randomizing both the animation type and the animation speed. So these are what my user flows look like. I got 4 of them, or my feature set. So you can follow along and do. Thank you. All right, so what does that look like? Well, I'll click play. Let me maximize it. So in last week, I cleaned up the user interface. I put a nice little black backdrop to it. Centered up my clock. I got my little title information. I did expand the interface this week, so my buttons kind of like, I have new button areas. I got to clean this up. But I kind of centered up everything, and it works really well. And so here I have a paint stroke. It's animated. I can switch out the paint stroke. So here's like multi-cubes. I purposely built this so that I have animation on the scale, but I can still manipulate the slider. It's still dynamic. Whereas if I go back to the previous paint stroke, my size slider is broken because it's being driven by the animation, and the code can't grab it. And I'm going to explain the differences of the two and why this is. And again, for sprint 4, we're going to have to just go back and fix this stuff because we're going to go back and refactor our code. And I got a third object, multi-cylinder. This one you can mess around with the scale. So let me turn off time destroy. And if you spawn these things, I can speed them up, I can slow them down, and I can even freeze them. So I have this slider here that is messing with the scale of it. So like normal speed, twice speed, all the way down to no speed. Yeah, these you can manipulate the size. Looks like the glow still works. The opacity still works. But the color is broken. And that's because part of this animation is the color is being controlled. So I'll clear that out, and I'll turn back on time destroy. And if I go back to the first object, I have one animation. I can switch the animation out. Now I have another animation. Let's slow it down a little bit. And if I switch to this animation, I have the third animation. All right. So right now, as my build currently is, I have 3 animations on this prefab. I have 1 animation on the others. But I want you, and I'll show you how to do it. You're going to create 3 animations. You're going to create your own prefabs, 3 of them. You're going to create 3 animations. You have full feature set. And I just showed you. Now I can mess around with the speed. I can do different types of animations. And for my own testing, I also did shortcut keys. So here's like one animation. I can swap it to another. And let me turn off time destroy. So I'm just pressing the 1, 2, and 3 key. And I'm doing this because it's slow. Before I actually integrated this with the user interface, I wanted to make sure that my different animation transitions worked. And it's quick for testing to see if everything's correct. Your animations look okay. And we'll go over this part. If I clear this out, the last part is you can randomize the type. So now it's randomly rotating, scaling, or doing that position thing. And if I turn off type and turn on speed, it's let me reset everything. Nope. Looks like my random type is broken. I gotta look at that. Okay. I still have some bugs to work out in my user interface, but here we go. So here, the speed, what I wanted to show you, the speed on the scale is different. They're all doing scaling effect, the scaling animation, but they're all doing it at different speeds, at different random amounts of speed. So you can randomize speed and randomize type at the same time, and then, or you can turn them all off. So I see the last type that gets randomized is being set, but my UI is not being set. So I got to fix that for next week. So that's my full Sprint 3. I have everything exposed through the user interface, and I have this like build out of content. So I have 3 prefabs, each with 3 animations. I'm able to change the animation type, change the animation speed. I'm able to randomize the type and speed. And I want you to do the same stuff. All right. So the last thing I just want to note before I move on to actually going through all the parts is that when I press 1, 2, and 3, notice how the UI is being updated. So because I introduce a shortcut key and I'm changing the same information, I'm changing the animation state, I had to make sure I had to go tell the user interface, hey, you need to update when the user is using the shortcut key so that the user interface is up to date when we're using the shortcut keys. And it looks like I just need to do something similar with the randomization effect. I need to have that update that information as well. All right, so before I start going through the prefabs, is there any questions?
So you said that we had to come up with new features for this one?
Yeah, these 4 that I'm doing. Or you can do others, but this is the amount. Yeah. So it's a pretty new area, and as I'm slowing down a little bit and just tackling over these 2 weeks. So if I click on click detector, notice that I have 3 prefabs, painted object 0, 1, and 2, and down in my prefabs folder, I have many of them. So as you're creating new prefabs, you can easily drag and drop them and test them. So for example here, if I wanted to swap out cube animated with cube scale and give it a go, This is an updated effect, or a different prefab that has a different animation running on it. So I'm just going to leave this on screen for a second. So when I created, I can just talk about animation briefly for information design for it, or techniques for it. Notice how it's creating this type of like pulsating effect. It's got this glow moving through it, and it's got this like scaling effect, and the combined motion, the combined animation information gives it this pulsing effect. So I wasn't aware that this was going to happen when when many cubes on the scene are animating just offset a little bit time-wise. My animations are just based on one prefab, so will yours be. And so I just did a simple, or what I thought was a simple animation on one prefab, and what happens is you get this emergent behavior. So when you paint out many, in this case maybe there's like 50 on screen or something, it does something very different, or the feel of it looks different than just that one cube doing this. So this was like a happy coincidence. I like this effect. I kept it, but I didn't intend it to do this. So as you're building out your user flows or your intended features, sometimes you run into these scenarios where you're not quite sure how it's going to be delivered. You're not quite sure how it's going to be designed or the final effect, but you know that it needs to feel right from a user's perspective. So this is like just from what I think is the right amount of complexity to make it interesting enough. If something is not complex enough, it's to the user or to a person, it's rather boring. If the pattern is very simple to figure out, it comes across as boring. If the pattern has some complexity to it, where your mind has to kind of logically work out what these patterns are when it sees it initially, but it's not, and it understands there's a pattern, but it's not quite able to figure it out, it needs to sit on it a little bit. That's kind of like the good amount of interest, engagement factor. And when it gets too complex, the pattern can come across as noise or disturbing, annoying, and it can frustrate the user. So you kind of want to find that nice balance of just enough complexity that it's interesting, but it's not overwhelming, it's not distracting. And so do simple animations and test them when you're painting out, when there's like 50 of these objects are animating on the scene, on the screen. And then this gives something that's kind of interesting to play with and use, and it can be identified as like a good feature. But as I speed it up, maybe it's too quick, it's too noisy. You could start to maybe see that we're breaking the fun factor of it. The other thing I wanted to talk about with the complexity was multi-cube. Oh, I remember now. So if I swap back to cube animated, another animation I created was this one. So if I just click one real quick, there's a few there, but it's just doing a loopable circle. It's moving left, right, up, and down. There's just changes in X and Y, but it's hard-coded in a certain location. So no matter where I'm painting, they're all like flying over to this hard-coded position and then animating in that position. So this was another unattended effect. So it came out through this type of emergent behavior that I really like. It's like everything's flying over no matter where I'm painting. And then they enter into this like hard-coded little location change. So, maybe in Sprint 4, I would like to try and build upon this where I really like this effect, but I don't want it to always be moving to this one location. Can I make it a little bit more dynamic, but still kind of maintain this, like, it's being like this pull, this like gravitational force is kind of happening to it. So again, unattended, I liked it, and I kept it. So I'm going to bring cube. Now he has multiple animations. I want to bring one that just has one animation. This will work. All right. So let me go over to scene view. I'm going to pop this in the world. Once this instantiated prefab is in my scene, just to like mess around with, update, manipulate, and then I like it. I click apply and I delete it. It's just here to work on temporarily, because the main feature of the app is they get spawned in dynamically. But if I click on the object and I see in the animator, its state machine that controls all of its different animations, that there's one animation. Technically, there's one down here. I have another one. It's not connected together. But what I really wanted to show you is that this is the simplest situation. It's one object that has one animation. Then you can click over to the animation window, click play. This is what the animation looks like. You can take a look at the different keys. Are the value changes over time? You can look at the curve sheet, look at how those changes between those points are happening over time. Do whatever changes. You can add more properties to animate, what have you. So this is the simplest situation. And as I click on animation and animate it, click on it, notice how up in the inspector, the scale is blue and the numbers are driven. And if I clicked my scale tool, oh, I didn't know that you could do that in preview. So it's letting you override the animator. I wanted to show you that you can't scale it because the scale is being driven, but it looks like they let you do that during edit time, but that's not the best, because then if I put it in here, I wanted to show you that if you're driving a parameter, you cannot interact with it code-wise because it's being overwritten. But what's happening here with multi-cube, why can I change that scale dynamically? So we have cube scale. It has an animation on it. The animator is sitting at the root, driving the scale right at the root, which is also the area that we go down to when we, in our code, that we grab and change with our UI. So if I bring in multi-cube, open it up, we have an animator at the root, but the animator is driving scaling information on its children. So if I click play, if I click over to animator, notice it's a similar setup. It just has one animation on it. If I click play, these three objects are animating as siblings to each other. They are not driving or overriding each other. So last week I made a sphere, a child of a cube, and I made it rotate around it, but then when the cube rotated, the sphere kind of came along, and when it scaled, it got mushed and deformed as well. And that's a hierarchical or a parent-child animation. Here, these are siblings. They are being driven by one animator, but they are not impacting each other. And as I click on each cube, notice how their scaling information is being driven by the animator. But as I click on its parent, or the top of the prefab, none of its information is being driven by the animation, which is why I can scale it. So I can still grab this whole prefab at the top of it, get its transform, and still manipulate. You can manipulate everything, the position, the rotation, and scaling. Whereas something where if we're animating the object right at its root, we're not going to be able to grab that scaling information. So this is going to be a preferred scenario. And probably in Sprint 4, I'm going to update my one cube to have like a parent, and so it's animating underneath, so then we can grab it at its parent level. But that'll be a Sprint 4 update or refactor. But now we have this idea of sibling, or multiple objects being driven by one animation. So if I bring in multiple cylinders, similar situation. It's got a parent game object. That one has an animator at the top. It has one animation. And I'm going to simplify the animation right now. I'm just going to kill this rotation part to it. If I click play, it has 3 scaling features. It has a capsule, center, right, and left. Each of those we're manipulating a scale on it. And so they're offsetting each other. They're doing different scaling animation. But they're still just siblings to each other. They have independent animations. So if I stop this, and what I'm going to do here is its parent, I'm just going to rotate it 360 degrees. So notice I have the top of the prefab, the parent selected. Notice how the rotation is blued out. It's being used by the animator. And if I click play, not only are the siblings animating separately from each other independently, but now the parent is rotating, and they're all inheriting that rotation from the parent. So we have 2 types of animation systems. We have this we have multiple objects all doing their own thing, all being controlled by one animator. And in addition to that, we can animate the parent to give it, like, the whole system of objects have a similar animation feature. So they're all scaling independently, but the parent's rotating. Now I can't grab this prefab and manipulate its rotation by code now because it's being driven by animation. But if I just turn these all off and click play, I'll switch over to multi-cylinder, turn off the time destroy. I can change the scale on them. And so if I draw some multi-cubes, those can change as well. But if I draw the cube, that aspect, that prefab is not dynamically updatable. So in sprint 4, we'll have to fix this. And then I can try messing with the glow. It looks like that is all changeable, updatable. And the opacity, it looks like the 2 on the top left are updatable, but the one on the single cube is not updatable. It looks like none of them are impacted, are dynamically updatable with color, although the future drawing of them are. So these are some fixes I'll look at for sprint 4. But it's okay to follow along with me and get it to this level. So now we covered different ways to animate or to create an animation with a single object, multi-object as siblings, and multi-objects that can inherit like a parent animation. Now I want to look at how to create multiple animations on an object. Before I do animations, actually, it was better to cover colors, rendering, when we just talked about these objects. So we have multiple types of prefabs now. They all have a common characteristic that no matter how they're being built, the animator, there's one, and it's at the root. But we have some instances, for example, where this cube, its shader, the render object of it is at the root. And then we have some instances, for example, these multi-objects, where there's no render at the parent. The parent just is like a container. It's for positioning, scaling. It's for playing the animation. But the objects underneath all have a renderer, and we need to get access to them and set all their renders to something random, something different, when it gets spawned, and later on when we want to change these color values on previously on already existing painted objects. So these 4 lines you're used to. This is in the update loop where we're spawning objects. Here we're figuring out which shape we should spawn. Here we're figuring out how much should we stretch it based on its previous one that got painted down. And here we're generating random colors and random emission colors to place to update the color attribute on the material of the render of this object that we're spawning. And we have a reference to it. But we need to do a check now. You need to say if primitive, which points to the root or the top of our prefab, if it has a renderer component, then we're going to assign that renderer a color. So what we're saying is if primitive is what we've just instantiated, the copy of the prefab that now lives in our game world. If it has a render, meaning it's not pointing at null. So if we have a null pointer, a 0 pointer, there's nothing it's pointing at. This component doesn't exist. So if getComponent does not equal null, meaning it is pointing at something, then we're going to generate a random color. We're going to assign it to that renderer's material and the color of that material. And we're going to generate this emission based on that color information and then assign it to the emission color of that material. So something like cube scale, where it does have a renderer right at the root, right at the top of the prefab, this if statement will be true, and it will go in and will generate a random color, assign it, random emission color, assign it. If it's something like this multi-cylinder or multi-cube, the root, the game object at the top, does not have a renderer. We'll have a null pointer. The pointer will be 0. It will not point to anything. But its children do have renders. So we'll deal with that next. But that's why this says if this pointer actually points to something, update that color information, and then I put this in. This is implicit. You don't need to put this in. Else do nothing. So only if this render exists at the top of our prefab will we execute this block of code. Else we do nothing. Then we have to go through its children to see if they have renders. Now my prefabs, the way that I'm currently building them, only have one prefab that has no children or a prefab that does have children. I'm not having grandchildren and getting more complicated beneath this. So I'm just checking, doing a for each loop, which you've seen. I'm checking if there's children in this actual instantiated prefab. Now you're used to looking through a list of currently created prefabs that live underneath our click detector script. So down here, for each transform child in the transform, so this script is a component that lives on our click detector. So it is actually looking underneath here. So when I click play and I start spawning stuff, it starts filling up game objects underneath here. That's what this for each loop structure is doing. Now notice it's just looking in the transform connected to this script. Up here, we're looking in primitive.transform. So the current instantiated prefab that we just painted, that we just created, we placed on the scene, we scaled it in some way. We're looking underneath it. Does it have children? And we're only impacting the children if they do. So in this case, multi-cylinders has 3 children. Multi-cubes has 3 children. I hear you. So in these, it says for each transform child in primitive.transform, we're going to do a check. If that child.gameObject, if its render is not connected to null, meaning if it's connected to something, we're going to generate a random color, and then we're going to go back to that child, go up a level to its, because the child is its transform, it's a component on that child game object. We're going to go up to its game object, we're going to find the render component on it, you know, get its material, get its color, and assign it to this random color. Then we're going to go through Can you just wait till I'm done with class? I can hear everything. We're going to create the emission color, and we're going to assign it to that child's render material. So these are the children game objects under your prefab, if they exist or not. We're going to actually update their material. So we're looking at the root level, and then we look at the children. That's why every single object of your prefab can have a random color to it. So now we looked at the fact that we have single object prefabs and multi-object prefabs, and how to handle them in their animation window, and how to handle them with the material change. So yeah, let's look at multiple animations now. So if I bring in cube animated, this was my first paint stroke that had multiple animations on it. In this case, I have an animation for scale, an animation for rotation, and an animation for position. And here's my 3 animations. And here's what that looks like at the animator view. So besides the fact that we have more states now, we have these white lines, these transitions between the states that we can set when to switch animations on this object. So I'm just gonna cut these, and I've been making an animation per class. So I have a cube bounce, which is the scaling effect. I have cube rotation, he just kind of flips back and forth. And if I click on this prefab that I dragged into my scene, I can go to the animation window and create new clip, which is a new animation. So if you go to the animation window, I can open it up over here. We can see that we have animators, which look like that, animations that have the play icon, and I'm going to create a new animation. So I'm going to call it Cube Class 03. So since I did it that way through the animation window, it actually created a state for me to use in my animator. And it's referencing this Cube Class 03. So if you didn't do it that way, you could right click and say create state, create empty, and then you can give it a name. So, you know, another animation, and then you can connect which animation you want to play with it. But you don't have to do that step if you just do it this way, where you go into the animation window, click on the object, and say create new clip. So at the end of the day, I have a new animation here. So let me just do add property, add transform, add a position. I won't do the full circle. I'll just move it from 0.0, and I'll just move it up like 2 units. And the Y, I'll just move it up and 0. Zero that out and click play, and then here's my new animation. So if I go back to the animator, this is the new animation. I can click on one state, say make transition, and it looks like this little white line, and connect it to my other state. And now we can move from cube bounce to cube class 03. And then if I right click make transition, I can connect back to my other animation state. And now from our initial state, we can get to this animation, we get to this one, but we need to transition between these two. So as you can see, I have my transitions built out. Now I need a way to tell the animator when to initiate these transitions. So this over here are the parameters. If I click on the plus sign here, we can do any type of basic variable. We can do floats, ints, bools, and triggers. I don't think you've been exposed to. They're just like simplified bools, where a bool can go back and forth between true and false. The trigger just goes like in one direction, kind of resets. Now, for me, when I was trying to figure out which parameter I want to use, I looked at the user interface and I figured, oh, I'm going to eventually use a drop down. I'm going to open up the drop down. I'm going to select which animation I want to pick. So a drop down is an enumeration. It's just like this little custom list of elements, little strings, and each one is identified to another number. We always start from 0 and increment up. So 0, 1, 2, 3, and so on. So I have three animations. I just called them scale, rotation, position. And I know that the drop down, I want to link up to that. So whenever we use this drop down element and we select one of these elements, we know it's going to send an integer to our script. So why don't I just make use of that and say, okay, I know I'm going to be receiving integers, and that's how I'm going to be transitioning between these animations. So if I have an enumeration that starts at 0, say I have 3 animations, I know I want to go 0, 1, 2. So this animation, the scaling, cube bounce, is our default animation. So this I'm just going to assign it arbitrarily my integer 0. I have rotation as my second animation, which will be assigned 1. And I have position information, or change, which will be my third animation, which will be position 2. So you can select an int and call it whatever you want. And just remember this name because we'll reference it later. For me, I just called it state, lowercase. And I defaulted it to 0 because it's going to go into our default state, our default animation. So if you notice, I click on this transition, it populates the information of it in the inspector, and it transitions when this condition is met, when state equals 1. So when we move from state 0 to state 1, we do this when our state variable, our int called state, equals or set to 1. And if I click back on this transition, we transition back from state 1 to state 0 when state equals 0. And I just set this up because this is how the drop down is going to work. And I just make my animator work in the same fashion because it's a lot easier. I don't have to do different math. I don't have to check for different variables. I know that I have 0, 1, 2. So I just made these transitions over here, right? They're not set up yet. I only created them. So if I click on one of them, what you're going to have to be aware of is that by default, they're time-based. That's what this has exit time means. It means this initial animation state will run all the way through till its end, and it will transition to the next one. It's not determined on user input or any type of interactivity like that. However long you make that animation, it runs and then it transitions. I don't want that. So I'm going to turn off has exit time. And I'm going to go down to conditions, and I'm going to add a condition. Since I only have one parameter called state, it populates the list. We're good to go. We want to set it to equal. And where are we going? Well, this is the blue one. This is the one we have selected. We're going from scale, state 0, to state 2. So that means our variable, our parameter, has to equal 2, because that's just what we set up. So when we go from state 0 to state 2, our condition is our integer must be equal to 2. So when we go back from state 2 to state 0, we're going to turn off has exit time. We're going to add a condition that state equals 0. And then these are new as well. So I got to click on them. It's not time-based. I'm going to set state equal, and I'm going from 2 to 1. So state must be equal 1. And then in a similar fashion, we're going from state 1 to state 2. So it's not time-based, and state must be equal to 2. So I have 3 animations. I created them and I played them individually. They all look fine. And then I talked about how they're going to have this emergent behavior when you have like 50 of these things animating. You kind of have to play a stroke and see what it looks like. And you're happy with the animations. Now you have to create these transitions. And as I click through them, notice none of them are time-based. And they all have some condition where state must be equal to something. So I checked through my transitions. They all look clean. So we're good to go. So I've built my animator for this one prefab to have 3 animations. All 3 animations have transition points, all based on this parameter. Now this parameter is like a public variable of type int. So each time this prefab is instantiated into our game world, it'll have its own animator with its own parameter that we can mess around with. And that parameter will change these different animation states. So by default, that state will be set to 0. We're going to go into that first animation. But we've set up a dynamic animator that we can impact, we can change as we care to with our code. So how do we test that? I'm not ready to go into the user interface yet. I just want to test that this animator works. So the first step would be you just click play. Now let me get out and maximize on play. So first step is I've got just this one instance. I built this animator, these 3 animations. I built all the transitions, which are 6 of them. I built this parameter on this animator. Let me just click play. It still lives in my game scene. Notice how this is filling up with blue and it's looping, and you can see the animation is playing there. And if I went to the animation window, no, it's not. You don't see anything. But you see here that we're in this state. It's currently looping. So I can go to this parameter and I can press 1. Notice how I just jumped to the second animation. Oh, let me pop back. So here, over here, the parameter. So here I'm in the first animation state, which we're calling state 1, or state 0. I can switch to state 1, and it's really quick, but you can see this line fills up with blue, it moves. And now we're over here into our second animation, our state 1. And then I can press 2, and now we're in our third state. And very quickly, you jump through that transition, and now we're into 3. So I'm testing it. Everything seems to work fine. I can move between my animations. This one prefab seems to function. So I'm going to delete it from here. Now the next step is I want to call that animator by code. So I have a private int called animation state in my click position manager script. I set it equal to 0. The animator by default goes into animation, or what I call state 0. So I'm just mimicking that same information here in my script. We have a private int, animation state 0. And the first situation I'm going to make use of this is here. Very similar to how we handled the renderer. Right above here, I do a check. If whatever I just spawned, this primitive, whatever it's pointing to, this reference called primitive, whatever it's pointing to, if it has an animator at its root, because we're building all our prefabs with the animator right at the top. So if this pointer is not null, means it's actually pointing to something, ignore the rest of this. This is going to be for next week. All I'm doing is this. If this animator exists, then go get it and call a method called setInteger. So just as you saw other parameters, there are such things as other methods like setBool, setFloat, setTrigger, but we're just creating an integer. We're saying setInteger. We're passing in the name of the integer that we want to set and what do we want to set it to. So in this case, back at the animator, cube animated, my parameter was just called state, lowercase s. And then I'm setting it to whatever animation state is. So by default, that's 0. So now we have to test changing it and see if it updates future strokes. So I'm going to cancel this. No, I'm not going to cancel this out. So at the top here, I'm checking for 3 new inputs. And this is the first time you're checking for keyboard input. So you're used to saying if input get mouse button, either down, up, or just get mouse button, and then which mouse button are you checking? Left, right click. We're doing get key down. So we're checking if somebody is pressing the keyboard, one of the keys on it. And then you're going to use this key code. So this is an enumeration, kind of a custom built dictionary list of values. You don't need to actually go deep into understanding how this hardware is connected, interfaced with the software, because somebody already did it with you with these enumerations, these list of values. So if I just do key code dot and look at all these that are available to you. So all these alpha numbers, those are the numbers above your actual alphabet numbers. So that big horizontal row of numbers. You have all the actual letters like A, B, you have asterisk, ampersand, alt, backspace, colon, comma, the delete key, down arrow, everything that's on the keyboard. All the F keys, all the function keys, joysticks we're not mapping to. And the keypad, that's the right side, the numpad. So we're just looking at, is the user pressing alpha 1, 2, or 3? Right at the top left, 1, 2, 3. As a side note, you can also look for key combos or modifiers. So this is how you do like copy and paste, Control C, Control V. You would check if somebody is holding down the control key. So get key, key code control. And if the user is just pressing the C key, so like get key down, the C. But here we're just saying if the user is pressing 1, 2, or 3, we're going to run this method called change animation state 0, 1, 2. All right, so I'm passing in an integer into this method. So this is just the, if you remember, I'm kind of pulling all this back, that the drop-down functions as enumeration starting at 0. And so I set up my animator to have its parameter starting at 0. 0, 1, 2 is how we're transitioning between our animations, only because the drop-down sends these integers. So these are the same numbers that I'm passing in. So even though I'm pressing 1, 2, 3, and I'm sending 0, 1, 2, yeah, the numbers are a little offset, but this is the only place that they're offset. And we're doing this to make math nice and easy, straightforward with the animator and the UI. And the user never sees this difference in numbers anyway. The user, if they're going to use the keyboard shortcuts, it's just like, oh, 1 for animation 1, 2 for animation 2, and so on. So what's this change animation state like? So here's our method. It's public because the user interface element, the dropdown, is eventually going to call it. It's void. It doesn't return anything. And it's passed in an integer, and we're calling that temp. So we just have to look at this right now. This is how we're going to change our current and our future painted objects. So whatever integer we're passing into this method, we're going to update our animation state integer. So if I'm pressing the 1 key, we're passing in a 0. If I'm passing in the 2 key, we're passing in 1, and so on. So where are we using animation state? Well, if you remember, we're up here in the update loop where we're spawning objects. And we're using that integer, that animation state, to set the animator when we're first creating something. So here we were checking, which colors, which children have renders, where we're going to add colors. Here, all we're doing is, if this newly created prefab has an animator, well, here's its animation state that we're setting. And what are we using with that? The animation state. By default, that's set to 0. But if we ever press the 1, 2, or 3 key, that value will be changed. And eventually, when we build the UI, we're also going to change it that way. So this line right here is changing how what we're currently spawning will be impacted. Just ignore this line right here. I'm going to explain this later. These lines of code impact the already spawned objects. The objects that currently live in our scene are past painted objects. So what are we doing? For each transform in this current transform, this script lives on our click manager. Anything we paint goes underneath our click manager script. So we're looking at objects that are already existing. So if we found one, we do a check. For each child, we check, is there an animator on that child? If so, we're going to set that integer on its animator to whatever we just updated, whatever we pressed as either the developer or the user, 1, 2, or 3. We change state 0 to 2 on already existing elements. All right? So I'm just going to save this. And I'm going to go back to maximize on play, and I'm going to click play. And that's the wrong object. I have to connect in cube animated. So this is why I paint an object. I can press 1, 2, and 3. Let me turn off time destroy. And all objects, whether they currently exist or newly existing, now get their animation set to whatever that number is I put into it. All right, 1, 2, and 3. So I'm able to connect to my animators correctly of both currently existing and yet to be existed objects. So I don't like that up and down motion. I'm going to drag back in my old animation there. Let me just double check it actually functions right. Yep. All right, so now I can quickly test if my animators connect up, and I can switch between animations. So let me talk about how that connects to the user interface. Is there any questions up to that point? What do we got? We got about 10 minutes. I got to talk about the user interface. And that's it. All right, so we're good. So for me to create the user interface, all I did was I selected the drop-down primitive that was used to select which type of object should we be painting. I just duplicated it and called it drop-down animation type and positioned it somewhere else. So I positioned it there. And then I went down and I named it its options to scale, rotation, and position. And you can call whatever your animations, animation 1, 2, or 3. Now, whenever the user selects any of these, it's going to pass an integer off to some method. And we have to set what method it's going to send that to. So in this case, I connected my click detector. And I said, okay, we're going to use this click position manager Sprint 02 script. I should probably update Sprint 03. And then we have to pick which method we're going to call. So this is, I see this happening sometimes. Notice there's dynamic and static. You always want to be picking dynamic. Otherwise, if you pick static, I don't even know if this is available under static. Yeah, it is. So change animation state. Notice how there's a number here. If I put a number in, no matter what I pick, that number will always be passed, which is not the correct functionality. I don't want just a static number being passed that I'm telling it to. I want it to pass a dynamic end. Change animation state. It's public. I can access it. Dynamically pick from 0, 1, or 2, whatever the user wants. Send that number back to my script. And that's it on the UI side. And it's calling this method, and it's passing in an int, 0, 1, or 2. And it's setting up the future painted and the past painted objects with this functionality. So one issue that can arise is, let me click play, let me make sure the user interface works. So this is what the scaling animation looks like. This is what the rotating animation looks like. This is what the position animation. Okay, my user interface works really well. But what if I'm using the shortcut keys? Well, notice how it's updating the user interface. So based on the animation that I'm changing with my shortcut key, I needed to go back and send information the other direction to the user interface to say, hey, this information, this int that we're controlling these animation states, which is stored on our click manager script, has been updated by other means. It was updated by a shortcut key. I need to go tell the interface so that they're representing the same information to the user. So how did I do that? Was this line right there. So you're used to information coming out of the user interface and updating our scripts. Whatever the user wants, they can pick this and that. That information is sent to our scripts. It's updated. You've also seen the other direction with this mouse position and these numbers on these color sliders and like changing these little text areas when you move the slider. That was sending information back to the user interface. So I connected to different parts of the user interface, mostly text objects, and I passed strings back and updated those texts. Now we're going to update a different part of the user interface, the drop down. So first off, do using UniEngine.ui, because it should already be there and we have to interface with the UI library. We're going to create a public reference of type dropdown. If I hover over that, it's the uniengine.ui.dropdown. And that's the UI element that we happen to be interacting with for animation type. And I just called it something like anim dropdown. And when I save the script, and you let it compile, you're going to get a public variable, and it will be none by default. But then you got to hunt down into your user interface. You got to find the anim dropdown. That's the right one. That's great. So I got to go back to click detector, find my dropdown, and drag it onto it to say this is the dropdown element I wish to change. When you do that, now we can write this line of code. So this is in our change animation state. Whenever this is called, either by the user pressing the shortcut keys or by the user changing the dropdown, it's going to go back to the dropdown. So anim dropdown dot value. This is that integer value that gets changed and sent out when you interact with the dropdown. We're going to actually set it with our own code. What are we setting it to? Well, we're setting it to our integer called animation state that was just updated. So if the user presses 1, 2, or 3, this temp integer comes into this method. It changes our animation state integer, and then we also pass that off to the user interface. Now, technically, this might not be the cleanest code because when you interact with the dropdown, the user interface element, you select a certain value from this dropdown list. It's already taken care of itself. It already knows that it updated the value. In fact, it sent it to us, and then we did our own internal changes, and we sent it back to the UI dropdown. So if you select the last option, which is value 2, and it sends us 2, we update on our side, and then we pass 2 back. And so we're just overwriting 2 at 2, which is not the best. So maybe we could do like a check here. If this method call was coming from the shortcut key, then don't run this line of code or something. But it doesn't hurt anything. It's just technically it might not be the cleanest solution. But it's fine. It does what I need it to do, which is when you press the shortcut key to change the animations, the user interface is updated, reflected with that information, so it's current. It has the same information. I do see a little bug that when you randomize the type and you turn that off, I'm currently in, oh, in that case, it'll look like it updated. Let me try randomizing the type again. Looks like it's broken. Try it one last time real quick. Cube scale. Let's randomize the animation type. Oh, I commented it out. My fault. So I commented this out because as I was describing the features to you, I said we're doing this next week. So let me hold off on that. There's a little bug in there that gives me a week to fix it anyway. So what did we cover? We covered this aspect here that allows us to change the type of animation. We have 3 of them. This is the timing. So we've yet to cover that. We've yet to cover randomness in the speed or the timing and randomness of the type of animation that we're spawning. And that I'm holding off to next week. So this is more than enough. And again, I'm going to pull it back to here. I'm going to finish up explaining the rest of this, but I basically explained how to create 3 prefabs, how to create 3 animations per prefab, how to test them all. I went over how to change the animation type with the UI and also the shortcut key. And I've yet to go over changing animation speed and randomizing the 2 parts of it, the 2 changing the type and the speed. That's for next week, and then I'll build and you'll build and we'll be done with Sprint 3. Was there any questions? All right, I'm gonna stop the video. Yeah, I think covered everything.